All right, welcome. In this video, I'm going to talk briefly about a single miter handrail. You'll see it on round handrails quite often. I'm mostly on round handrails, and it's this one angle in between those two pieces is called the dihedral angle. It's what you would cut it if it was laying flat on the table. So if you were to put this in a chop saw with this piece straight, you could cut that angle and then flip it and around, and without rotating it, just and it would be on the right angle. It's well, there's two things that happen here. If you want that, you got to make sure that you put it in the right spot. The angle itself will be the same as this angle, right? Or just anywhere along the treads, like that. Enter. That's the right angle. However, that's not the right location if you're going to get your stairs designed. If that's where your stanchions were, right on the theoretical corner, that tread would be fine. So I'm going to touch base on that first. So what you need to do is design the stairs before you get to the handrail. If you don't, you're going to have problems, and I'll show you why. So typically your handrails are not going to be on the theoretical corner, right? So if I take this piece, take this handrail, take this stanchion 2, Control H. I'm going to move it over to the center of that plate. So let's say it's a 4x4 plate or something, because that's the dimension. So it's 2 inches from each corner. Then I'm going to lengthen that. And then this is that just an odd. Oh, so that's interesting. I move this one to Control Z. I gotta go back. So break line D. Okay. Oh, Control Z. All right, so let's select those again. Control H, put a handle on that. All right. Now let's trim that so it's down to the landing. And then this, won't trim into that yet, but let's do this. Let's take that too. What the heck? Put this here. Control H. And then go up to that point. Enter. Oh, like that. Enter. So that's 2 inches in each direction there, and then this should trim out to that. And now you see what you got is a bust there on the height. 2.5 inch difference in height. So what you have to do is you have to look at this dimension right here. Nice even number 4. So 4 inches. So everything here on this landing is 4 inches too far away. So you got to move everything here. So the handle is already moved. We're just going to move this in right there. Control H. We can just put it right there at the 4 inch mark. Enter. And everything gets moved in. All right. So now if we look at this, V, H. Zoom into there. Trim that. We could take that and everything could get moved up to that point. So you see the difference, instead of an 11-inch landing there, it's a 7-inch, right? 11 minus 4, right? So that's how it goes. But that's not the only way you can connect it, but you really do need to design that. And then if we trim that, and this H, forgot to move the handrail too. There you go. So there's your single miter. You can join these two pieces, and then you can extrude this along this. Control H, and then draw, extrude along the curve, and then hit that, have the handrail. So what you do need to keep track of, though, is when you put this on the table, so we're right here, so that's how you draw it, but this is the angle that we're looking for. Alt MA, K and K. Text is 35, double text is 3, okay? I don't think that's right. So 106.75. So then when you put that on the table, you make sure you center punch at the top, and on both pieces, I would do it at the end and very close to the handrail, right, almost in the weld zone, a center mark, so that when you cut it and you flip it around, you know where the top is. Otherwise, it's just easy to think you're putting it together right and have it there could be an error. You're going to need that if you're going to prefabricate the stanchions on there. Here we go with the calculation for that 106. You don't have the 3D computer. Then you do your rise and run to a landing and a rise and run to a landing. It's just one tread because all you're looking for is the angle. And let's see, so we're looking for this angle here. So what we're looking for is we need this diagonal, right? This one here. Let's just draw the triangle. Need that leg, which is going to be the same, and then we need this long diagonal here. All right. So to calculate this leg, we need to do this leg, right? We did that with the 11 squared plus 7 squared. You get the square root of that, you'll get 13.038. Same thing here. And then we need to get this length. We need to get this diagonal here, so we're going to use this triangle here. So we need this length right there. You get that with this, this is 11, and this is 11. So the 11 squared plus 11 squared, get the square root of that, you'll get this 15-inch leg here. And then you have this rise as 7 and 7. I'm not sure if I did that one. 11 squared plus 11, that should be 14, right? So let's do this. Tools, calculator, square root of open parentheses 14 squared. It's not 14, it's 14 squared and 15 squared. We're looking for this diagonal length, right? So it would be, there you go, 15 squared plus 14 squared. That's the height of this. And then get the square root of that, you get this 20 here. All right, so what I did was, that's 13 and 03, 13, 03, and 20. That's the three-sided triangle. And it's a scalene triangle. Well, it's actually an isosceles triangle. It's probably easier to do, but you can do the law of cosines. And there's the law of cosines for a. A squared equals a squared minus b squared minus c squared, all divided, which means you got to put it in parentheses, divided by 2 times b times c, negative 2 times b times c. And then that'll give you 106. If you get the arc cosine of that, you get 106.75. So that's what I did, and that formula is exactly where I got it. I go like this, copy, go to tools and calculator, control V, enter, you get 106.75. So that's how you calculate that angle, Alt N A. All right. I hope that helps you understand a little bit, get a little bit better, and taking care of making the handrail right, making sure you see that coming ahead of time. If they talk about a single miter handrail, make sure that the geometry of the stairs and landings works out to wherever they could be. You know, your rails could be on the outside of those there, and it would just change it different, right? But the angle would be the same. This angle won't change, but the geometry of the treads coming into the landing will change for sure. Hope that helps in your career, and thanks for watching. Have a good day.